Hello everyone. Till now, in this chapter, we completed two exercises. In first exercise, we learned about reflexive relation, symmetric relation, transitive relation, equivalence relation, and we did all problems in exercise number 1.1. In second exercise, we learned about one-one function, which is also known as injective, and we learned about onto function, which is also known as surjective. And we learn about bijective also. Bijective means a function which is both 1-1 and onto. Complete second exercise based on these definitions. Now, third exercise, two definitions are there. One is composite function, another one is inverse of a function. From this third exercise, 1 5 mark question 100% guarantee in second POC. So in this class, we are going to learn about composite function and how we will calculate composite function. All those things we will learn in this class. You observe the definition of composite function. F from A to B, G from B to C are two functions. You know what is the definition of a function. F from A to B, G from B to C are two functions. Then composition of F and G. Composition of F and G is denoted by G circle F. You try to understand this point. F, G are two functions. F is from where to where? A to B. See here, this ends with B. G is from where to where? B to C. It starts with B. This is important note. F from A to B. G is from B to C. It ends with B and it starts with B. That is the point you need to note down. F from A to B, G from B to C are two functions. Okay. Composition of F and G. Composition of F and G is denoted by G circle F. Some people they read it as golf, ghost, something like that. It is not like that. You need to read it as G circle F, not golf. Some people say golf, fog, like that. It is not like that. You need to read it as G circle F. The composition of F and G is denoted by G circle F. Here second point you need to note down. Composition of F and G. F and G is denoted by G circle F. Listen this carefully. Composition of G and F. Listen. Composition of G and F is denoted by F circle G. Please try to understand what I am saying. Composition of F and G is denoted by G circle F. Composition of G and F is denoted by F circle G. Okay, notation. So composition of F and G is denoted by G circle F. And what is G circle F? G circle F is a function from A to B, A to C. G circle F is a function from A to C. G circle F from A to C is a function. How it is defined? G circle F of X. G circle F of X means G of F of X. G circle F of X means G of F of X. For all X belongs to A. You see here, this set A. So what is composite function? F from A to B, G from B to C are two functions. Then composition of F and G is denoted by G circle F. What is G circle F? G circle F is composition of F and G. How it is denoted as? How it is defined as? G circle F is defined as G circle F is a function from A to B. It is given by G circle F of X equal to G of F of X. You will understand. That's it. This is the definition of composite function. You will understand about this more clearly when we do the example problem, right? Here, this diagram you observe. Look here. F is a function from A to B. G is a function from B to C. Then composition of F and G is denoted by G circle F. And G circle F is a function from A to C. Look here. G circle F is a function from A to C. And G circle F of X is defined as G of F of X. I hope you are understanding. Now we will try to do few problems related to G circle F and F circle G. You observe this question. F is a function from R to R, G is a function from R to R given by F of X equal to cos X, G of X equal to 3X square. Then they are asking you to find F circle G and G circle F. You need to calculate. So first, F circle G of X. What is F circle G of X? As per the definition, wherever you see this circle, there you can keep a bracket. In the definition, what is the definition of composite function? G circle F of X is G of F of X. We written a bracket over there, right? So here F circle G of X means F of G of X. F of G of X. What is g of x in the, see here, in place of circle I just written bracket. What is g of x in the question? In the question given that g of x is 3x square. So in place of g of x you write 3x square. Okay. Now f of 3x square. F of 3x square you need to calculate. F of x is what? Cos x. Right? You want f of 3x square. You see f of x is cos x. What is f of y? F of y is cos y. What is f of z? F of z is cos z. What is f of p? Cos p. Like that, f of 3x square. F of 3x square is what? In this function, wherever x is there you write 3x square. So here we need f of 3x square. F of 3x square. In place of x here 3x square is there. So in the given function also, wherever x is there you write 3x square. F of 3x square is cos of 3x square. Okay. Now you calculate g circle f of x. G circle f of x is g of f of x. G circle f of x is g of f of x. Okay. G of, what is f of x? F of x is given as cos x. You write cos x. Okay. Now you need g of cos x. We know g of x. What is g of x? G of x is 3x square. G of y is 3y square. G of p is 3p square. G of cos x is what? G of cos x. In this, wherever x is there you write cos x. So 3 into cos x whole square, that is 3 cos square x. You see here, f circle g of x is cos 3x square. G circle f of x is 3 cos square x. F circle g circle f both are same. You observe, f circle g circle f both are same? No. F circle g not equal to g circle f. So as per this problem, we calculated f circle g and g circle f, and we came to know that f circle g is not equal to g circle f. In next class, we will do two theorems related to composite function.